Hello everyone. In the previous class, we have discussed about the basics of SR flip-flop. That is, we have discussed the working of SR flip-flop with its logic diagram. In this class, we will see the characteristic equation and the characteristic table and excitation table of SR flip-flop. So first, we will see why this characteristic table and excitation table is required. See, this is required whenever we are designing the flip-flop and counters. We require characteristic table and excitation table. So if I want to design if I want to write the characteristic table, basically I require truth table. If I want to write excitation table, I require characteristic table. So the truth table is the basic requirement, or the we have to know the truth table properly in order to write the characteristic table and excitation table. So first let me write the truth table for SR flip-flop so that I can easily write the characteristic table and excitation table. So as I have discussed yesterday, for SR flip-flop, I'll write the input. S and R is the input, and I will be assuming always the clock is high. So since I'm having two inputs, I will be having four combination of inputs, that is 0, 0, 0, 1, 1, 0 and 1, 1. For SR flip-flop, I'm having the two outputs, that is, in the previous class I have taken two output as Q and Q bar. So I am assuming that the Q is nothing but the output of next state, and that I will take it as Qn plus 1, that is output of the next state. So presently if I'm giving 0, 0 as input, what will be the output of Qn plus 1? That means output of Qn plus 1 is nothing but output of SR flip-flop. So yesterday, as we have seen yesterday, whenever I'm giving 0 and 0 as input for SR flip-flop, there will be no change in the output of flip-flop. That means output will be memory state, no change state. That means if the previous value of Q is 0, you will get 0. If it is 1, you will get 1. So no change is nothing but the previous state or memory state. So let me take the previous state as Qn, and the next state is Qn plus 1. So if at all S is equal to 0 and R is equal to 1, output is 0. S is equal to 1, R is equal to 0, output is 1. When both are 1, I told it is invalid condition. Why it is invalid? Because we will get Q and Q bar will not be complement to each other. So that condition we call it as invalid condition. So this is truth table. So next we'll go for characteristic table. So what is characteristic table? By knowing the present input and the previous output, I can predict what will be the output of the next state. So how can I predict the output of the next state? That is given by the characteristic equation, right? So this is characteristic table. Okay. So I have three input. So what are those three input? Qn. Qn is the previous output. Why previous output? Since these, it is nothing but previous state, previous output, and the present inputs are S and R. Let me predict the next output, or the output of the next state. So this is my output. These are my inputs. So what are my inputs? Present S and R are my inputs, and Qn is the previous output. Since I am having three inputs, I will be having 2 to the power of 3. That is 8 combination of inputs I will be having. So let me write 8 combination of inputs. 0, 0, 0, So these are the combination of inputs I have, right? So now by looking at the truth table, we can easily write the characteristic table. That means if we can easily write the output Qn plus 1 by seeing the truth table. So how will I write? So just observe the truth table here. So when S is equal to 0, R is equal to 0, what is the value of next state? So see here, when S is equal to 0, R is equal to 0, what is the output of Qn plus 1? Qn plus 1 is nothing but Qn. That is nothing but the previous output. So come here, when S is equal to 0, R is equal to 0, output is, I have to write Qn. But I know what is the value of Qn because here I was not knowing what is the previous state, but here I know the previous state is 0. So output is 0 here. Okay, so next S is equal to 0, R is equal to 1. Here when S is equal to 0, R is equal to 1, I no need to worry about the previous state. The irrespective of the previous state, output will be 0. So output is 0. When S is equal to 1, R is equal to 0. When S is equal to 1, R is equal to 0. Check the truth table. Irrespective of the previous output, the output is high. So the output is 1. Next, when both are 1, when S is equal to 1, R is equal to 1, it is invalid condition. So what is that invalid condition? Here it is not valid. So when S is equal to 0, R is equal to 0, see the output, it is memory. Memory is nothing but I will get the value of Qn. Next, when S is equal to 0, R is equal to 1, I will get 0. 1, 0, I will get 1. 1, 1, I will get, when both are 1, it is invalid state. So this is the characteristic table. So next coming to excitation table. So excitation table is nothing but what are the minimum inputs required for exciting the state, exciting the output from one state to another state. That means I will be knowing the here outputs will act as inputs and we will be predicting what will be the input, which input combination is required for exciting the output from one state to next state. So that is what the excitation table is. So for excitation table of SR flip-flop, I'll write here excitation table. So for excitation table, I will consider Qn and Qn plus 1 as my input. So this is nothing but input. For these combination of input, what is the what is the value of S and R required? So since this is nothing but output. So the inputs, since I'm having two inputs, I will be having four combinations 0, 0, 0, 1, 1, 0, 1, 1. So if I want to get Qn as 0, Qn plus 1 as 0, what is the input values which is required? That is nothing but excitation. That information is given by excitation table. So when you will be for excitation table, you need to know the characteristic table. That is the reason I told truth table, characteristic table and excitation table are linked to each other. Right? So in characteristic table, you need to observe first column and last column. So you need to observe this column and last column. See, when Qn is equal to 0, Qn plus 1 is equal to 0. What is the value of S and R? See, I'm having two combination here. Here Qn is 0, Qn plus 1 is 0. So for these combination, what is the value of S and R? See, observe the value of S. For both the combination, S value is 0. R may be 0 or it may be 1. So irrespective of the value of R, if S is equal to 0, you will get the value Qn and Qn plus 1 as 0. So that means for Qn 0, Qn plus 1, S value is fixed. It is fixed to 0. R may vary either 0 or 1. So I will take the don't care values. So what is the meaning of this? S value should be 0 in order to get Qn plus 1 as 0. Next combination I'll take 0 and 1. Okay. Qn is equal to 0. Qn plus 1 is 1. So just check the combination. See here, Qn is equal to 0. Qn plus 1 is 1. So for this combination, what is of any other condition? Is there 0 and 1? No. You should check in the table whether any other values are having 0 and 1 for Qn and Qn plus 1 respectively. I don't think I'm finding any values. So for 0 and 1, the combination of input is S is equal to 1 and R is equal to 0. So here S is equal to 1 and R is equal to 0. Next for 1 and 0. 1 and 0 is Qn is 1, Qn plus 1 is 0. So here Qn is 1 and Qn plus 1 is 0. So for n and 1 and 0, the value of S is equal to 0 and the value of R is equal to 1. Next for 1 1 combination, you will not be having the values because we will not be using this condition. So this is invalid condition. I hope you understood this table. Truth table is required for writing the characteristic table, and for writing the excitation table we require the characteristic table. So this is how we write the characteristic table and excitation table for SR flip-flop, which is very much required whenever we are designing the counters. Thank you.